All right, today is December 31st, 2020, and I wish a Happy New Year for you 2021. And in this video, I'm gonna talk about multiple objective programming in feed formulation. Actually, I'm gonna make this video short and sweet, and so let's get started. I'm gonna share my screen and okay. So first of all, we need to know what multiple objective programming is. In fact, it is a combination of stochastic and maximum profit programming models. In my previous videos, I talked about least cost programming using the linear models, maximum profit models using the nonlinear programming models, and also stochastic or margin of safety, again using the nonlinear models. In this video, I'm gonna show you how we can combine stochastic or margin of safety models with maximum profit programming models. In fact, both of them are following nonlinear programming models. And our goal is to maximize the precision in our feed formulation. So what we're gonna do is we're gonna start off the maximum profit feed formulation spreadsheet. So I'll put the link for the video where I talked about maximum profit feed formulation. Just in case, if you have not watched that video, you need to watch that video first, and then you can modify the spreadsheet, and at the end of the day, you will come up with multiple objective programming, hopefully. So what we're gonna do is we're gonna add SD values or standard deviation values for protein and amino acids in the maximum profit feed formulation spreadsheet. So in fact, the second step is related to stochastic feed formulation. And you remember that from the stochastic feed formulation video. So I'm gonna start off the maximum profit spreadsheet and just start adding SD values for protein and for amino acids. So as you can see, I am adding a new row for standard deviation values of each amino acids. And I need to add one more for threonine and the last one for tryptophan. There we go. So the next step is to copy and paste the standard deviation values for protein and amino acids from the stochastic spreadsheet. And if you watch stochastic feed formulation video, you can see that when I was creating the ingredients table, in fact, I included the standard deviation values, and I talked about the resources that you can use to, find these values. So this one is for lysine. There we go. And I copied and pasted. For methionine, I will do same. I'm just, copying the ST values and pasting over here in my maximum profit spreadsheet. And then for methionine and cysteine, again, I'm copying those values and just paste here, and 2 more to go. Thrown in ST values. And the last one for tryptophan. The ingredients that we used in maximum profit fit formulation and stochastic fit formulation are same. Okay. Now, the third step is to add protein and amino acids modifiers coefficients. It is exactly same as stochastic fit formulation method. So I am going to just copy and paste. But before that, because I'm going to, in fact, bring modifiers here, so I'm just going to change the location of the final formula. Now I got space here to bring the modifiers, and what happened here? Okay. Copy and paste them here. Okay. I'm just gonna double check the values. Okay. If you look at protein modifier formula, it says B9 times B28 to the power of 2. So B28 actually is inclusion rate for my first ingredient, which means that corn. And B9, here we can see it is calcium level, and it's not correct because it needs to be ST value for protein, because we are working on protein modifier coefficient. So we need to insert a ST value for protein. So ST value for corn protein is in cell B8. So here I need to change it to B8, and then I'm good to go. And I can just drag this formula to the right. So now I have corrected all of the coefficients for ingredients. And I think I need to adjust the SD cells for all of the amino acids as well. So lysine modifier, as you can see, it is B15 times B28 to the power of 2. So B15 is for methionine, and I need to change it to the SD value for lysine. It is 14. So in fact, this will be 14. As you can see, what happens is the number of the SD cell needs to be decreased by 1 point. For example, see, for methionine modifier, I changed it to B16. If I go to B16, it is SD value for methionine. So I need to drag it to the right to correct it for all of the ingredients. And then I will repeat same thing for methionine plus cysteine. And for threonine and the last one is tryptophan. As you can see, for example, for tryptophan, it says tryptophan modifier is calculated by multiplying cell B22. B22 is the SD value for tryptophan by B28, it is the inclusion rate, to the power of 2. So I'm just gonna drag it to the right. As I said, it is imperative to watch my previous videos, especially maximum profit fit formulation and stochastic fit formulation, in order to understand this video better. So I've got extra values for SD rows. So as you can see, I can just delete them. It's simple because in these rows, I mean for RHS or nutrient per ME, we won't have any formula because we added extra rows just to add the standard deviation values for protein and amino acids. All right. So the next step, step 3, we added protein and amino acid modifiers coefficient. The next step is to add new nutrient specification column based on stochastic models. If you watch stochastic feed formulation video, you will see that nutrient specification calculation was a bit different, and in fact, we added the confidence level that we are going to have in fit formulation, and we multiplied it by sum of modifiers, protein modifier coefficients and amino acid modifier coefficients. So what I forgot to do is, in fact, I need to have probability level and the norm negative of norm sieve of probability level as well. So I'm just gonna add them here. Okay, as you can see, we talked about that in stochastic fit formulation. Here is probability level, and here is minus norm sieve of cell H37. It means that the probability level. So now we have added stochastic models in maximum profit spreadsheet. And I'm gonna add one more column, named it nutrient specification, and I can call it stochastic. And I'm just gonna change the format. So we will have same format as nutrient specification that we had already. So what I'm gonna do is, it will be same for all nutrients and energy, except for protein and amino acids. So I can just copy nutrient specification column and paste the formula over here. And to have the same digit numbers, I can just click on format cells, go to number, and change it to 4 decimal place. So as you can see, both columns are exactly same. And we are going to change the nutrient specification just for protein and amino acids. That's all. So this is the protein nutrient specification. I clicked on this cell, and in the formula bar, I'm going to add plus. So minus norm sieve value, this one, I37 times SQRT of some of the modifiers, because I'm working on protein modifiers. So it means that I need to select row 30. And I'm going to close the parentheses. I need to put 2 parentheses to close it. And now you can see this value, 19.83, is different from 21.5, because this nutrient specification takes into account the ST value of proteins. So I need to do same thing for lysine and for other amino acids. See, now lysine 1.29%. I need to add plus minus norm sim. It means that this cell, right, times SQRT. As I said, if you watch the stochastic fit formulation video, you will see that I have explained all of these over there in that video. So now, if you just compare the values, nutrient specification for lysine is 1.29. I mean, it is the old value, and the new value where we are taking ST values into consideration, it dropped down to 1.25%. So I'm gonna do same thing for methionine plus I37 times SQRT sum of methionine values or methionine modifiers impact. And the two parentheses. Yeah, it's correct. Here is correct. And now I'm going to methionine plus cysteine. So we will have same thing for methionine and cysteine times SQRT of sum of methionine plus cysteine modifier coefficients. There we go. And we will have the same thing for threonine. I'm gonna add I37 times SQRT of sum of threonine modifiers. And the last one is for tryptophan. So plus I37 times SQRT of sum of the modifiers for tryptophan. Okay. So you can see I have added a new column named nutrient specification for stochastic. We are moving to the next step. It is adding new RHS column based on the new stochastic nutrient specification. So RHS was right-hand side of the model. If you remember, I explained it in details in Maximum Profit Fit Formulation video. So here we do have RHS. I'm going to just insert a new column and call it new RHS. Okay, so the new RHS, in fact, will be the combination of nutrient specification based on stochastic plus the sum product of ME value by nutrient per ME values. If you look at the formula in old RHS, you can see we multiplied the inclusion rate of ingredients and also this ME value of the diet by the nutrient levels of ingredients and minus sign of nutrient per ME values. Again, if you watch maximum profit feed formulation video, you will see all of these explanations in details. So here, what I'm going to do is I'm just going to write formula equals nutrient specification based on stochastic plus ME value of diet times this cell. It's empty, but because I'm going to drag it down and it will be repeated for all cells, I'm just putting that. But if you see T28, this cell contains ME value of diet. So it will be same for all of the calculations. So I'm putting the cursor just here, and then I'm pressing F4, and you can see dollar signs have been added to the sides of T, and it means that I fixed this value. Okay, by pressing enter, you can see it copied down for all of the cells. But for cells like U5, you know, we don't need any calculation here. Or for the cells where we added ST values, again, we do not need any calculations. So now this one is the new RHS. For example, if I look at protein value, we can see the formula is similar to old RHS, but we have calculated it based on a stochastic nutrient specification. So if you were wondering where we need to apply stochastic models in the maximum profit feed formulation spreadsheet, it is the place where we are adding those models. It means that we need to add stochastic models to RHS column in maximum profit spreadsheet. So by this, in fact, we have combined maximum profit models with stochastic models. And now we can call it MOP, or multiple objective programming, which is much more stronger than the previous methods. So if I look at the steps, I have added new RHS column based on the new stochastic nutrient specification. I need to go through one more step and it's done. I need to replace the old RHS by the new RHS values in the constraints window. So if I click on data and then click on solver, we can see already we had some. I'm just gonna zoom in so you can see better. You can see in constraints box, we had some constraints for RHS values. So previously, those values, RHS values, were in column U, but then I added one more column, so they moved one column forward to column V, and the Excel automatically changed the new column in the constraints window. So I can see here we said V23 should be less than or equal to X23. It means that if I look here, it is talking about this cell, right? This one is RHS should be less than this one, the maximum number. So what I'm going to do is change the V column to U. So I'm going to click on this and press change, and instead of V, I need to put U because the new RHS values are in column U. And okay, and I'll do that for others as well. So I'm going to change this one. Instead of V, I need to put U. It means that U4 should be equals to W4. If you look here, in fact, U4 is weight of the diet, right? It should be equal to W4. It means that the final weight of diet should be 1. Okay. And here, I've got V6 to V23 should be greater or equal to W6 to W23. I need to just change it. And instead of V, I'm going to put U column. It means that new RHS. Because new RHS is based on stochastic models. And I can double check to see if there is any more V column, and I can see there is not, and I have changed all of the old RHS values to the new ones in the constraint window. And now I can formulate the diet by pressing solve. And I can see solver found the solution, and all constraints and optimality conditions are satisfied. I'm just going to press OK and accept this formulation. And then I can see my final formula over here. So, as you can see, dietary ME level is 3.05 megacalorie per kilogram. If you don't like this value and you want to decrease it, what you're gonna do is just decrease the value for maximum amount of protein that you have put here. For example, I can change it to 2.95 and I can formulate the diet again. So now I can see my dietary energy level changed, and now it is 2.95, and for sure it has decreased the dietary cost as well, and the new dietary cost is 44 cents per kilogram of diet. So that's the MOP method, or multiple objective programming. I hope you have understood it and you have enjoyed it. Again, please let me know if you have any question, and I'll try to answer your questions.